Hello students, I'm Himani Sharma, your UGC NET educator. In this new YouTube video, we are going to move forward with the concept series on Paper-I UGC NET, right? Teaching and research aptitude is the whole paradigm under which we study different units, we all know, right? So today, the topic of ICT concept series that we are going to deal with deeply is language processors. Now, before even jumping on to what are language processors, what is an assembler, compiler, etc., interpreter for that matter, we are going to first of all see that what types of languages does a computer understand, what are the different types of languages, and what do these particular language processors do when it comes to, translating the high level or the low level language into other types of language. So first of all, let's just see what do we have in here. First type of language which is really important, that is machine language or machine level language. So machine level language, as the name suggests, is the language of the machine. So what kind of machine are we talking about in here? We are talking about the computer system. A language of the first generation of computers, it contains binary digits. Now, one concept which is really important, that what do we mean by binary? Binary digits in here means that two digits are used. What are those two digits? 0 and 1. So when you will see questions in your NET examination where they ask you to convert the number system from binary to decimal to hexadecimal, so you know that the binary digits are 2 in number and they are 0 and 1. Correct? This language is made up of instructions in all binary forms, which means that it will be containing only these two numbers. This will create a particular code, and computer understands zeros and ones only. Computer does not understand that I am writing here my name. It will not understand that. But first of all, it will convert whatever I have typed through the keyboard to the binary language and then provide with the output of, yes, I typed Himani through the keyboard. That was the input. Then it will show or, portray the output on the monitor or the desktop screen. That will be shown what I have typed. But first of all, it is so speedily done that this thing, and I'm not saying that this thing stands for Himani, of course. This binary digits combination is what works particularly, and of course the computer comprises of these two digits, zeros and one, and it understands those very things. It is usually displayed in hexadecimal form, that it becomes easier to read, right? This language relatively tough for programmers because of the fact that we as human beings are built up with that kind of mind where we understand A, B, C, D, E, F, G, H, I till Z. We understand 0, 1, 2, 3, 4, 5 till the infinity number. But we do not know that what will this particular code mean. And I, as a normal human being or someone who's programming, we won't be able to memorize these many combinations which are formed. So we can see that, yes, that is why this language is of a computer, and for programmers, it is relatively tough when compared to other types of languages. Hence, machine language. Then we have assembly language. Language of the second generation of computers, correct? Though it is similar to function with the machine language, the difference is that instead of using binary digits, it incorporates names, right, which make this language much more programmable. We will see here, it will have an extension such as MOV, which will mean that it is a movie, it is a video that you are going to watch. So of course, if any programmer is using assembly language, that coding is kind of easier and in a human readable format. You will be knowing that what you are getting in here, unlike the combinations of zeros and one which were there in the machine level language, correct? For instance, the commands given in machine language are in the forms of ones and zeros, as we already talked about in the previous slide. The commands given in assembly language are in names such as MOV. right? Which is an extension. This language more readable than machine language. Hence, of course, it is easier to program certain programs, like, make certain applications using this particular language because it is humanly readable. Then we have high level languages, language of the modern generation. So machine level language, that is the language of the first generation of computer. Then we had assembly language, second generation. Then we have high level language, that is of modern generation. Programmer friendly, advanced, most easily readable memory out of all the two languages that we have talked about, and this one being the third. This one is the easiest of them all to program. The commands in this language are in English language, hence it is the language of the human beings only for that matter. So a person who knows English language will be able to create a program or something like that easily using high level languages. Compiler is used to translate programs programmed in high level language into either machine level language or assembly language. So you see here, one language processor is already visible. Compiler compiles the data, of course, the language, and translates, converts it into machine level language or assembly level language for the computer to understand. Some common examples are Java, C++, where you do coding and you, of course, create certain, programs, software, so on and so forth. First and second generation can be categorized into low level language of the computers, whereas third and fourth generation can be considered under the high level languages. We are clear with the languages. Now we are going to see what are language processors per se. So also known as, first of all, language processor. It is going to process the type of language which is there, correct? So it could either be machine level language, it could either be, it could be assembly language, it could be high level language. So it will be processing, it will be translating or compiling the codes whichsoever is provided there and translate it to other level language so that the computer produces something, correct? So language processors are always and also known as language translators, right? And language compilers that analyze, processes, transform code or text. Why are we talking about text? Because, of course, the text wali language is high level language, which is written in a specific programming language or natural language. So a question could be asked that in which type of language natural language is used, right? So we know the answer to this one, high level language, because it is humanly readable and mostly the coding whichsoever is there is in the English language. Communication between humans and computers are possible through these very language processors, because you write it in English and it gets translated to the binary form in the machine level language, and then the data is produced again in your language, correct? Crucial in various stages of software development, including compilation, interpretation and assembly. So we need these three units working together to produce a software. Hence, these language processors, translators or compilers are used. So we have three types: compilers, which will translate the source code. So source code could be, let's just say, machine level language, and it will translate it into the target language. So we have two types. I will give you an example here, that let's just say that the source code, my language is Hindi. This is an example. So let me just write here, this is an example, and this is not a computer value example, just generic example I'm giving you here. I use Hindi, correct? But I want someone to translate it into, and I am in a conversation with the foreigner. So I do not know English. So I want someone to translate whatever I'm saying in Hindi to English. Now the person who will be here, the mediator who will be translating it, will be whom? Will be the person who will be knowing Hindi and English both, correct? So that will be a bridge. That will act as a bridge between the person who knows Hindi only and the person who knows English only. That is the work of a language translator or a language processor. The language that I'm using here be it machine level language, high level language, or low level languages comprising of the assembly language as well, the language processor will change it into the other language by using language processors. I hope things are clear to you now, right? So first of all, we have, so this is the source and the target language in which I want the program to be translated, that is known as the target language. So source and target, we are clear with that. Interpreters execute instructions directly without any prior compilation. We'll see the differentiation between the two of them. And then we have assemblers, which will, as the name suggests, convert assembly language into machine code. So any program which is having, extensions like MOV, we will get it converted into zeros and ones, the binary digits of the machine code. Now, first of all, we are going to talk about compiler. High level source code, so it is translating high level language, human readable format into low level. So high level, we know human readable or natural language to low level machine code. So it is, of course, as the name is suggesting, machine language. Use cases, it is used, the compiler is used in software development where it efficiently translates the code which is written in a human readable format for execution into what kind of language? Machine language. So hence, if you as a programmer, you are typing in something, you're coding something in English language, the compiler will help the program to get executed, compiled, etc. into what language? Machine language. Optimization performs code optimization for improved performance. So performance gets better when you use compiler. Similarities to other language processors. What are the two other language processors? Assembler and interpreter. This also analyzes and transforms code. We all see that. Enables communication between humans and computer, and these similarities will be similar for the three of the language processors that we are going to do. So first we did compiler, then we have interpreter. So it executes source code directly without any kind of prior compilation. We'll see, as I told you, use cases are in rapid prototyping where it will allow quick testing. So the compiler will first of all read the entire code and modification of code. In scripting, support scripting languages for automation tasks. So any, like, you see the bots, etc., the chat bots, they are the example here. Here again, analyzes and executes code, facilitates communication between humans and the computers, because of course these will work as a bridge. So one end is a human being which is trying to communicate with a machine who does not know his language, but the language processor will act as the bridge to enable that very particular communication. Then we have assembler, assembly language into machine code. So what are the use cases? Where do we use assembler? Low level programming, direct hardware manipulation. So any kind of programming which is supposed to be done in low level language, wahan pe we can use it. Embedded systems like compiles code for resource constrained devices, right? So in embedded systems like we have ACs which are embedded with certain codes, etc. There we use an assembler. Similarities, again, it analyzes and transforms code. What kind of code? Assembly language to machine level language. But it also enables, again, the communication between humans and computers. So the similarities are same for the three types of translators, language translators, processors that we have covered till now. Now, compiler versus interpreter, right? How the compilation is done versus the interpretation is done. So this is really important because this has been asked in the NET examination, that which one of them translates the code line by line and which amongst them translates the entire code, and then we'll let you know about the error and then you will be correcting. Compiler, entire source code before execution. So of course, it will translate the entire program. Interpreter, on the other hand, let's just see in here, this is a compiler. So first of all, you have written program. This compiler will translate the entire program in one go, and then of course, will let you know about the errors. Correct? Coming on interpreter, here, let's just say here we have interpreter, and these are particular lines of coding 1, 2, 3, 4, 5, 6. The interpreter will translate the code line by line. And when I say line by line, if let's just say it read the code, line 1 mein it was correct, but in line 2 it was also again correct. But in line 3 there was an error which was there. The program which was being translated in here, it will stop there. Then you will have to correct the error. Only then the next lines will be translated. So you get my point? Correct? So compiler may entirely it will be read. Errors will be shown at the end. And wahan pe in the interpreter, errors will be shown in the particular line and the program will only be translated further if you correct that particular error. Now compiler generally produces faster. So this one is faster because it reads the entire code in one go and then will let you know that error is there in this very particular line. So you'll just go to that very line and then correct it. Correct? So hence it is faster because entire code एक ही go में translate हो रहा है. Interpreter because it is reading line by line by line, hence it is slower. Correct? Interpreter offers quicker development and debugging cycles. Portability. Compiler generates platform specific binaries which are there, but here in interpreter works on any platform with an interpretation implementation. So basically the main motive of me bringing the compiler and interpreter here is to basically provide you with the differences which are there, and we have gotten most of the differences which are that the compiler will, compiler starts with C, so you can memorize it completely with the word completely, that it will completely read the code and then it will translate, it will provide the errors. Here in interpreter, one by one, you will have to go. So, translator, right, translates high level language into machine code. So, compiler and assembler mein, what are the differentiations that we have? Compiler mein, the translation of high level language into machine level language is done, whereas in assembler, assembly language into machine, we have already covered that. Assembler, as the name suggests, assembly language into machine code, that is zeros and ones mein convert hoga. Translate source code one line at a time. So here the translator that we are going to talk about in here is, it is the interpreter. The interpreter translates one line at a time. Compiler, the entire code, right? Here it uses the processors, the processor which is there in the computer, the desktop, the laptop, etc. It will use the processor instruction which is there to convert from assembly language to machine level language. Majorly, these two differences are asked. Needed every time you run the program. Translator, interpreter is needed every time, but here you only need it once to create an executable file, and till the time you time and again come back and you visit and execute that very file. If you created an executable file, it will keep on opening up. Runs quickly as conversation between two low level languages. What are the two low level languages? Of course, assembly level language and machine level language. High level language, so of course it is already there. So it runs quickly as a conversation between both the low level languages take place, and it is reliant on the processors. So just one thing which is added onto in assemblers in here through this very particular chart is that the assembler is dependent on the processor for any kind of instruction when it comes to translation. Here returns a list of errors found and on which lines. The interpreter will let you know that yes, 1, 2, 3, 4, 5, 6. So in third line you have the error. Interpreter will let you know that in what line the error is there, will only inform you of the first error it finds, and then of course it will let you know. Runs more slowly. This is slower. this one is a little faster because it translates the entire code there and then. Examples here are word count, which is a basic language processor counts the number of words. As the name suggests, word count ho jayenge words, right? So it will be easier for you all. Text summarizer. The processor takes a long piece of text and that it will provide you with the summary of the text, correct? Emoticon analyzer. So we have emoticons like this. We have emoticons like this. We have emoticons like this, right? The smirky one. So of course, emoticon analyzer will analyze the emojis, right? Processes text to identify and classify emoticons used in the text. Then we have language detector to see what language is being used, in which language the text is particularly written. So we see in certain bottles, there is Chinese, we get confused between Chinese, Japanese and Korean, right? So we do not know, I do not know particularly. So I use Google Lens for that matter to translate it. So language detector will detect the language in which that particular thing is being written. Keyword extractor. This scans a given text and it will let you know to identify the most significant keywords or key phrases. Most of the times it is used by the content writers to see through the SEO optimization, for the SEO optimization which keywords will work best, correct? So this is what we were supposed to cover in the language processors of ICT, and with other concept series, with other topics, we are going to move ahead with the concept series, correct? I'll see you again. Till the time, you all keep on studying. Thank you so much and have a good day.